Well, hi, good morning. Welcome to my shop. Thank you for coming and keeping me company here while I face some interesting questions, I guess, about this radio and try to figure out what to do next with it. So just to recap very quickly, I have succeeded in bypassing a defective IF transformer pretty much in its entirety, the second transformer in the radio. I know that because I was able to listen to radio type sounds coming through from the antenna out the speaker. No surprise, not very loud. I had to have the volume turned right up to hear anything. And I certainly didn't hear a real radio station. I didn't make an attempt to do that. So where am I at here then? Have I discovered that in a rudimentary way, using these decade boxes and stuff like that, I've been able to contrive a bypass circuit, bypass the defective part sufficiently now that this radio has a chance. Gee, I don't know about that. The volume was very low. We don't know what's happened to the bandwidth, or we know what's happened. The bandwidth, the receiving bandwidth has gotten much wider, I'm sure, from lack of the second IF transformer. And we appear to have lost some amplification along the way, aside from just the transformer. Depends upon how they've done the transformer in this radio. There may be a voltage increase going through the defective transformer, if it were working, of course. And that voltage increase has been sacrificed by the bypass method I've put in, which is just basically to feed the signal through a capacitor from the IF amplifier to plate circuit right over to the detector diode. Now, a couple things about that. I've been thinking about this, of course. The secondary side of the defective IF transformer is still in the circuit. It's a wire coil whose resistance, I don't know, let's just pretend it's 1,000 ohms. So basically we have a tube with a grid. Basically we have a diode, and we have a 1,000 ohm coil grounding it. We're going to have to look at the schematic to get this really straight, but we can think of it this way anyway. That 1,000 ohms is not very much. I'm feeding the weak signal into the top of it, and it's got a choice of going through the diode doing its thing, or just zooming down through the coil and disappearing. I think I have to do something about this coil. I got to get it out of the circuit. Or is it still resonant? Would it still be resonant? Could it be it's still resonant, but it's no longer resonant at 455 where it should be. It's now resonant a little bit off, or maybe a long ways off, because I've brought this capacitor over. The capacitor I'm using, if you want to believe my decade box here, is 0.0002. It's very small. No, I'm going to take that back. It's a 0.0005. It's still pretty small. Perhaps, as I changed capacitors here, changing the loading on that secondary coil, changing the resonant point in it, and certainly detuning it in the sense that a Q is going down. The bigger the capacitor, maybe the more the signal, but the more the detuning and the disruption of the circuitry. See it there? That's the circuitry. Yeah. Okay. So all those things may be playing a factor in the very, very low output that's coming through the radio. But there's another thing that may be playing a factor in a low output, and it could be the speaker itself. The speaker is full of holes. Look, this is a gigantic flappy hole here. There's holes everywhere. Just looking at it now and thinking about what I'm thinking. You know what? There's enough speaker here. The speaker itself cannot be responsible for the loss of volume, not to the degree that it's gone. Those breaks in the cone, they might cause distortion and funny sounds, buzzy sounds coming out of it, but I don't think they would knock down the volume. Okay, so how do we explore all these questions? Well, tuning of the secondary, we got to look at the schematic and sort this out for sure, but just off the top of my head, tuning the secondary transformer on the second IF might do something. I wonder if we could analyze this better with some signals from a signal generator or something like that. You know, another thing that could be knocking down the volume is bad capacitors. I still have numerous bad old capacitors, maybe not bad, in here. Some of these are responsible for conveying the audio directly. So off the volume control, the signal comes out, it goes into this capacitor, which is in a metal shield. This is a metal shield, and the capacitor's been fitted inside of it here. Of course, that's done because of the sensitivity of the audio circuits is very high. So if you pick up noise here, and the signal being presented from the radio is very low, so any noise here is going to end up in your, coming out of your speaker and into your ears. You're going to hear it. So they've shielded this. If this capacitor is not conveying the signal well, that could be the reason why the radio is quiet. I've never heard this radio operate loudly. A couple ways to figure that out. You know, there's a phono input on the back here, but the guy who previous repair completely disabled that, and that's part of the picture here. Is what happened to that? But I could still feed an audio signal, I think, right into this point, basically. And we could hear it come out the speaker. But judging whether the radio is weak or not is difficult, because how strong should the signal be that I'm feeding in? I'm really not sure what it would be. So I would have a hard time imitating that, the radio signal, and then having it come out. I commented about this because I have a record player I could plug into this, and that would produce the right kind of signal level to go through the amplifier and produce a sound in the speaker. It can make a judgment. It's a ceramic cartridge setup. Pretty sure of that. So ceramic cartridges produce around a volt of signal. Now I could put a volt of audio signal on here and sort of imitate the phono and hear the audio come out. So another approach is to not do so much experimenting in that, but to start changing out these capacitors, ones which could be responsible for volume problems. Unfortunately, the one that's top of the list is this shielded one, and I don't want to change this because I don't have a shielded capacitor unless I can rip everything out of there and stick a capacitor in there. I don't want to do that. Not at this point. Could work. I could. You know what I could do here is get an audio signal, feed it, you know, in through the capacitor, and then just go get past the capacitor, feed it in down here. It's going right into the radio. Now that would prove out a few things, I think. That might be a good idea. I could really could feed an audio signal. Well, I could feed it in right here, but I could also feed it in to the bottom, top of the volume control, or right into the slider. Schematic is something worth looking at this point, I think. It'll generate some more ideas. I need ideas. Okay, ideas. So we're really talking about all this stuff in here. The capacitor, the shielded, you can see it right here. The shielded capacitor, see how they've drawn the shield right around it. It's just a regular capacitor, otherwise 0.005. I think we should try this and find out a good guess is the way I've got things arranged, basically a capacitor going from here to here, with the belief that this coil is open circuited. You have this small capacitor here, maybe. I also have a resistor I have installed basically across here, through here, basically. I have the resistor set for around 5,000 ohms. Now, maybe that's just inappropriate. All of that is inappropriate. Maybe if I were to increase the resistance much, much higher, I would get a higher and higher voltage swing here from the signal coming in. That'd be something we can experiment with if I can set up equipment to monitor the result, although to some degree listening to what comes out of the speaker is monitoring the result. When I was trying the radio, all I heard was just various noises, but one of them did produce an unusual sound that I'm used to hearing. It's not unusual here in my shop, kind of a boo. I can't imitate it. A little bit of a musical sound, so there is some demodulation going on, some audio going through. Another factor in all of this is a potential loss of the automatic volume control volume. And maybe even, is it even possible that the way I set this up caused a unusually high AVC voltage back here to quiet down the whole radio? There's another possibility. I would have to think my way through it, whether that could happen. I think the more likely thing is the AVC voltage just will never be there, because the signal reaching the detector is so low, because I'm bypassing this. This has been optimized for the purposes of the engineer who designed it. And this is typical. Almost all radios look exactly like this. They have the second IF. The odd radio has three IFs in a row. And so everything is optimized for this transformer to be here. If I were to be able to figure out how to re-optimize this, so it's a basic capacitor connection through here. This is the coil I believe would still be resonant. Would it still be resonant? So this is what I was talking about, the size of the capacitor I'm putting in here. I'm trying to let through as much signal as possible, but maybe with a bigger capacitor, what I'm doing is I'm detuning this circuit. Something terrible. We can find that out too. I have a sweep generator that'll sweep through the IF frequency. That might be the most interesting way to do this. Set up a sweep through here. You know what? I think that's probably the best thing to do. Figure out how to set up a sweep signal through here. Then we can look on the oscilloscope and see what's going on. We can also employ my SDR to take a look at what's going on with signals in here. I'd have to think about that a little more too. Lots of things to think about, so a good place to do that is with a cup of coffee. I'm going to go drink some coffee and then decide which one of these I want to attempt. Well, lots of options here. There's probably another 20 options I haven't thought up yet. So here's an interesting piece here. This is from Antique Radio's website. And this is from, I think, a book or something like that that was written on it, and part of the book has this topic, Bypassing Defective Audio and IF Transformers, by Norman R. Leal. And he describes exactly what I'm up to here. So here's the circuit of interest that he's showing. He's showing a 200 picofarad capacitor, and what I've got is something like it's a 200 picofarad capacitance according to my decade box. And that's something funny, exactly the same. There's two things about this diagram though. He hasn't shown the resistor that has to be in place here to convey the B plus to the tube, to get the tube operating. On the audio version of this, he shows it. But he left it out of this diagram. Or whoever made this diagram left it out. So we can assume there's another resistor here. He would say roughly 20K. and what I'm using is 5K, and maybe I'm a little low on it. His comment is the size of this capacitor is not critical as long as it's small, something like that. He doesn't comment on this. What are these two X's? They look like it's an instruction to remove this wire, disconnect this part of the transformer. I don't know, something wrong with this diagram. Because if you have this disconnected, this statement up here won't make sense. Where he says somewhere, I gotta read the whole thing. We do the same with the intermediate transformer. If the IF transformer, with IF transformers, use small capacitors between the plate of the driving tube and the grid of the driven tube. This will allow peaking of the one side of the transformer which is still working, which is what I was just dreaming up here, looking at my bench a few minutes ago, that you could peak this still. And that this capacitor might be throwing this off a little bit. I don't know. Well, if you cut these wires, if you disconnect this, is peaking this going to do anything? It won't do anything. So I don't know. This is not all adding up here. I think we would leave this connected and experiment with the peaking of this transformer using this capacitor in place and the signal from here. And we'll leave the my 5,000. I could increase it a little bit and see what happens. A 5,000 ohm resistor. Okay, that's the story. Now, I've known about this bypass technique for a long time. Very seldom have I employed it, if ever. Maybe this is the first time I've actually employed it. So I think a number of things I've said, especially about setting up test equipment to get a good view of what's going on in here. I think that's really the next focus, is setting up a test equipment arrangement so we can see better what is happening inside this rear, especially the resonance of the secondary side of the defective transformer. That's what I'm going to do. Well, my first attempt at this has not worked out, but I'm going to show you what I did. I thought, well, what can I do without turning on the radio? Is there some test I can perform with everything switched off? And I think the answer is no, but what I tried was feeding a sweep signal in here. Okay, I have a capacitor connecting this through here. And then looking at this on the scope. And I'm not sure I'm looking at this actually. I can think of it now. I'll show you what's on the oscilloscope here. So here's the setup. Bunch of wires. Sweep generator operating here. I got the sweep starting quite low. It's starting at 260 kilohertz, and it's going up to 1630. So it's going right through the AM band, but starting so low it actually captures the IF frequency range, which I think is 455 for this radio. And then this is thrown up on the scope here. If I turn on the sweep, turn on the sweep, turn on the sweep, sooner or later, there we go. And the camera, we can take a little closer look at it and ponder what we're seeing here. So it's a little too bright for the camera. Let's see if I can fix that a little bit. So the sweep is going from, was it 260 kilohertz, and just off the screen here would be the top 1650 or whatever it was. So you can see it's widening out here. What I'm really expecting though is a peak somewhere right in here, or something right in here. This would be roughly 455 kilohertz, but it's nothing, it's smooth. I have a feeling I haven't got this connected right. You know, I'm looking at the results that reaches the input to the volume control, and maybe that's going too far in. What about here? Oh, what happened there? So now I got something really odd. I've got this dip way out here and a little blip right there. So let me try a couple things. You know, stupid, I'll tune the radio just because you never know what could happen. No, it didn't do anything. And what else could I tune? I could try turning the slug in the secondary coil. That I'm hoping it's still resonant, even though I don't see any resonance up there. So I'm just putting a screwdriver in and turning back and forth. So I'm looking at this, which I assume this is the 455 mark. Okay, turning one direction. Whoops, came out. Okay, let's go again. Turning one direction. It is moving. It is moving. It's getting bigger. And now it's getting smaller. So I don't know why it would get bigger or smaller. I think it's incidental stuff. Well, that's not very good. I mean, that's not going to help me. That's not going to tell me anything. So I think I'm going to set this up again. This time I'm going to utilize the radio in its operating mode. I'll feed the signal in much earlier into the radio, into the IF, and let it approach the circuit under test in a more normal way. And we'll try to pick it up. The results should be on the input to the volume control, I think. We'll try that. Yeah, let's try that. Okay, so picking it up on the input to the volume control would be over here. And we'll be looking for an RF signal at the volume control, which is a little odd, but we'll start there. And otherwise, everything here is set the way it was in terms of capacitance and resistance. And I think we're safe to go ahead. I'm going to put a capacitor in here to protect my signal generator just in case. I really don't want to blow up my signal generator here, so we'll just put a capacitor here. My guess is this won't impact anything. Signal generator going in here. And where's that? That's one leg of the resistor. I don't know. I got very confused. I'm very confused this morning. Too many wires going in too many directions. But I think I have it right. And most importantly, I think I have it safe enough I can try this. We still have an ammeter operating over here, so I'm going to throw this onto amperes. Too bad we use the terms amps and voltage. That's really too bad. When I was working at the power company, I had some old documents from 1910, 1915, and there was a discussion about the streetcar system and electricity flowing on the streetcar system in the city of Toronto. I didn't use the word voltage at all. They used the word pressure all the time. And he talked about, in this report, going out to a certain location and checking the pressure on the rails and the pressure between the rails. They didn't use the word voltage. That would be better if we used voltage, if we used pressure and flow when we said volts and amps. We'd be better off. Keep us aware of what the truth really is. Okay, enough of that. I've delayed a little bit. I'm anxious here because I just don't feel certain that I've done the right thing. I am in a confused state. So the idea was to put the resistor across the capacitor through the ammeter, which it is. So one side is the wow, I'm really in bad shape here. One I don't know why I can't get this into my head. I gotta stop and make sure I got this right. I don't want to go ahead on a guess. I'm going to get weird results. I'm going to make bad conclusions and disappear. I don't want that to happen. Okay, I think I got that sorted out. My antenna were definitely wiggling for a good reason. So I've moved the sweep input now way down to the 6SA7, which is the converter tube. So it's going in on the antenna grid, or grid 3. Then it should go through the radio in a normal way and show up. RF still should show up right at the volume control in this radio. I'm not absolutely sure of that. I didn't see a capacitor that was going to kill it, but maybe I didn't see something. So we'll try it like this. My probe here is on the times 10 setting. And what would we hear? There's no modulation in this sweep generator, but it is sweeping through. And if it sweeps through the tuned area, if I have the radio on broadcast band, which I think I do, as it sweeps through the tuned area, there may be a pop in the speaker, or a thump, or a whump, or something. Something may come out of it. It's very, very fast though, because the sweep rate is very fast. So it's going to sound like a little motor running. That's what might happen. Let's just center this up a little bit. Sweep is still running from below the IF to the end of the broadcast band. I think we're okay to start it up. What's that little drum roll sort of thing? Gotta keep an eye on this. This was 7 milliamps last time around. Okay, a little nervous, but okay, dim bulbs. Nothing happened. A video or two ago, I showed you a capacitor that had exploded inside this transistorized unit, and it had really gone off like a cannon. For sure, if a capacitor were to blast out of this radio in the same way that one did, and blow its guts right at me, I'd get a face full of hot paper. Flaming paper. Here we are. What do we hear? We hear the buzz I was talking about. So that's a very good sign. And we got weird stuff going on the scope. I'll get the scope picture up. Yeah, what's all that? Well, that's hard to say. My face on camera in the most spooky way. I can actually use my hand and point at stuff. Look at this. Look at this. Look at that. Well, that's a very unusual way of doing this. Now, I'm going to tune the radio and see if any of these move. Oh my gosh, look at them go. So, two of them have to do with the radio tuning. The one on the far left, I can point to it. This one. That's probably the IF. Why would we see this tuned one that are moving around? We're looking at the far side of the... well, you know what? We're running this radio with 76 volts. That's just not enough. And by the way, 3.9 amps. Because we're too low. 3.9 milliamps going through the tube. Too low. Okay, so we're going to put it on the full Monty here. Turn down the radio so we're not listening to that. Okay, we're at 6 milliamps through the tube. 105 volts on the radio. Okay, we're good to go now. Now, what do we see? Because I tuned the radio, one of the peaks has disappeared off the screen. Oh, what was that thing on the far left? Who knows? Oh, it's another one. Might take a lot of thinking to figure out what these are right here. This is the one I'm interested in, I think. I don't know what to think. Well, we wanted to try to improve things by changing the value of these resistors. I increase the resistor, the plate resistor. According to what I read, the value of the plate resistor is not very important in this kind of setup, although I kind of wonder about that. If I go way high, we're going to go way high with it. Okay, way high does that. Way high does that. Now the capacitor. The capacitor is as small as I've got in my decade box. Let's go bigger. That popping sound is just some wood banging. Oh, that's some interesting shapes showing up here. What is that? Oh, that's a reflection. Okay, but this is interesting. Looks like it comes down and does a little wiggle and takes off. The two of them are exactly the same. Even though I don't think they are the same thing at all. They look exactly the same. I'll tune the radio again. I'm waiting for my brain to go, oh! Where's the O coming? There's no O. O as in Eureka. I found it. What am I finding out here? Well, I set this up for a reason. What was the reason? I don't know. I'm going to go study my cup of coffee for a minute, because I think I left the reason back there in my cup of coffee. Okay, so the way I would interpret this is the IF signal coming through. So the sweep is reaching 455 and generating this thing. This is based on the local oscillator mixing and generating a product at 455. That's why if I change the tuning, I change the local oscillator, that one moves. I can't explain everything that's going on, but so what I want to do really though is I want to focus on this. So I'm going to change the sweep so it just runs from here to here. Okay, so I'll just do that. We wanted to start it a little higher. It's at 260, so we want to start a little bit higher than that. Let's say 380, and then we want to stop it at how low can we get it here? 455. We want to stop it at about, let's say 500. Okay, so that's about 500 there. Get her going. Okay, now we're looking more closely at what's going on in the IF. What the heck is going on there? Okay, that's pretty weird looking. Tune the radio, see if that does anything. No, it shouldn't either. We shouldn't see any effect from that. Oh, what's going on there? Who knows what's going on there? Something going on there. That's right at the bottom. By some chance, did the radio tune in all the way? No, all the way down to the IF. Okay, 5.7 milliamps. Oh, everything is good. A little bit higher. Now what? Well, now we want to tune the IF transformers. I wish I could find out exactly where 455 is on here. A little tricky to do, but let's assume 455 is right in this area for now. I'm not going to attempt to discern that just now. We'll find out what happens when we tune the tune. Just getting an adjustment tool here. It's going to work. I think this one will. So we'll do the first IF. Can. Let me get up close to the speaker. I can hear quite a good hum. Okay, watching what happens now. Look at this. Oh my gosh, what happened? Oh no. Okay, the slug just shot right in. When I went to turn it, it just shot in. It didn't, maybe I can rotate it out. Oh my gosh, what has happened here? This other IF can is all messed up. Ooh, I just pulling the slug. Another story's developing. So, either that clip here just isn't doing the job. Look at that. Now, doesn't that look a lot better? This radio is 16 miles out of alignment too. I'll try underneath here. The story's just getting more difficult all the time. Can I get in there? There we go. Yeah. So I don't know what frequency I'm on. I'm gonna have to figure that out eventually, but let's just get a nice curve out of this. Okay, that's a little better though. Although I don't know if it's 455. Doesn't matter. As long as the second IF, what's left of it, matches it. So here we go. Second IF tuning. So the bottom slug, I'm just guessing this is the, well, we'll know in a moment. If I turn this and nothing happens. If I can get the slug in. Get the screwdriver into the, there we are. Okay. Oh, lovely. That's lovely. A nice looking curve. Now I don't know if that's, maximum, a little bit of fiddling around and get it a lot lower, but we don't know what frequency this is. We just know now that it looks like all three tuned circuits in the IF stages are lined up on the same thing, whatever that is. It basically throws off the front dial if it's not right. Okay, good. What do we do now? Feed some regular radio signals into the radio, tune them in, and see what they sound like. And I can do that with the sweep generator if I just turn the sweep off and dial it direct to a particular frequency. And where's the radio tuned right now? It's tuned to the high end. I'm going to tune it roughly in the middle of the band range. So that we could guess that's around a million, something like that. Okay, so I'm going to stop the sweep. You can see the frequency now is 385. We want it to go much higher, somewhere in this range. And now, will we hear anything? I'll turn the radio up. The volume was very low during that escapade. The output's very low here too. We're going to turn it up. Well, how do you like that? Something there. Now remember, I'm feeding this into the grid of the mixer tube, not into the antenna. I'm going to stop. I'm going to turn on this other signal generator over here. We're going to feed an antenna type signal into the radio and get some notion as to what it's really doing at this point. Because I'm clued out. Because it's so convenient, and I have the antenna right here, we're going to put the antenna on and see what we hear. So first of all, turn it down a bit. Oh, that's really good. Let me clip it right on. It's really good. It's making a lot of noise. Noise is good. Okay, antenna on, volume up. Well, okay, that's not so good. Could be this. We'll attenuate this. Now that's not even connected anymore. How can it do that? Because I didn't disconnect it. Yes, I did. I disconnected it. Where's the lead from here? Oh, you know what I did? Okay. I see what I did. I did not put the antenna on. I put the signal generator back on. Here's the antenna. Here's an antenna. I think this is switched on. Okay, so we'll ground it. And then we'll put the antenna on. Okay, volume up. Volume, oh, the volume was up. She's full blast. Tuning. Can only be described as really weak. Now, there could be other problems making it weak. So that's a powerful interference signal here in my shop. And the volume is up full. Not a good sign. Let's turn the volume down, remove the ground from the antenna. Sometimes that makes an improvement. Oh, wow, okay, I made a big improvement. Turn around. Okay, we're getting down in range of radio stations. go and check to see if make this a little more interesting if I do this. Go down and make sure the antenna's connected. Interesting stuff. Right in here. There's that sparky interference I hear all the time. Yeah, I'm going to run down and make sure the antenna's connected. That's interesting. Yeah, the antenna's switched on, and as I walked back in my shop just now, before I turned on the video again, the ticking went tick, 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 and stopped again. What the heck is that? So on the broadcast band, my outdoor antenna is crappy, but on the shortwave bands, it's not so bad. So I'm going to flip to a shortwave band here, if I can. Oh, Jimmy got a shock. Jimmy got a shock. Oh, what a dummy. Got a very minor shock there, but still, I don't like getting shocks. I do not like getting shocks. Stupid of me. What did I do? I grabbed onto this and put my hand on that stupid thing right there. No, Jim, it's not stupid. You're stupid. You are stupid. There. That improves safety. Think hard, man. Think hard. Think hard. Okay, right. Changing the band. Okay, we're on one of the shortwave bands. Volume is cranked up full. And that would sound like nothing to me. Okay, next band. Lots of crackling there. Next band. So we would hope to hear that rushing sound, right, of the noise. There's nothing. Okay, I'm going to reconnect the ground because sometimes that helps. You never know. Okay, volume is still all the way up. Nothing. It's coming through. Okay, I'm now going to revert to my original plan, which was to start up this old signal generator over here and apply a signal from here, because I'm very familiar with this piece of equipment in terms of the output level. I'm not so familiar with this guy. So we are going to completely disconnect the no sweep involved. Antenna input. So we're getting rid of the real antenna. I'm going to put in this guy here. Jim, where are your hands around this thing again? What do I do with the paper? It's on the floor. Okay, I got to do something a little better about that, I think. Or I'm going to be, fool me once. You know how that goes. Even the meter's laughing at me. Haha, you got a shock, he says. Come on. My patience is running thin, so I'm going to have to get out of here. That's what I'm going to have to do. I'm getting into a state. Okay, think, man. Okay, so the output is on the antenna from here. And I'm familiar enough with this guy to make some sense of what's going on. So let's put this on the broadcast band. We know it. Okay, that's the broadcast band. We're about the middle of the dial. This is set to 1.3 megahertz, so it's right in the range. Let me calibrate the output over here. Yeah, just go away, meter. Yeah, see my patience. No patience. Okay, so we're calibrated. We have a 1000 hertz tone at 30% modulation. We have a strong signal coming out of here already. The volume is turned up. We're radio's on broadcast band. I will tune this now and hear if we can hear it cross the tuning point of this radio. Everybody quiet. And the answer is no. Tune the radio to a little higher. Oh, how do you like that? See, I was just out of the range of this. So now we heard it. We heard it. Bring it down. So now I can get an idea how much signal I'm sending into the radio versus what's coming out of the speaker. And this is relatively good news. This is a signal that would come from a strong antenna. Nothing overly strong, but a strong antenna would produce this level of signal. Got the volume turned up all the way though. If I turn the volume in the more normal range, not much left. If I turn this down, we turn this up. Whoa, blast it. Blast one in. And by gosh, it works. So, just to convince you, convince myself. So we're sending in roughly 1,000,000 hertz, and it's tuned roughly to 1,000,000 hertz. Hey, what about these IFs now? Okay, so just doing this, just winging this along. Chances are they'll only go downhill. I'll start with the second IF because I did the quick tuning earlier, but let's try this. Just using the ears. Use your ear bones. There we go. Going down. Well, not much difference there. Right? Oh my gosh, this whole thing's turning. Did I determine it? Well, yeah, that's right. This is the primary coil. This is the secondary coil at the bottom there. It's not very good. I expect this to really make a big impact. Getting quieter now. Okay, well, it's only one lone coil. Let's put it up here. Try the other one. Again, just winging it here. Okay, here we go. Okay, based on my guess, it would be there. It's not really a guess. And I'm watching the scope and that of this upper one. Yeah. Okay, so we don't know if they're lined up at 455, but they're lined up at something. And so this will give us a good idea of what this set's capable of under the current configuration. I thought this was supposed to be small. Small. Oh, I can see on the scope it's going down. Let me see if I can just get this to trigger. I don't think I can necessarily. Okay, filter. Okay, there we are. Got a high frequency reject and my scope will looks like, so I'm guessing that this fat part is the RF that's still in the audio signal. And is that really audio? Yeah. Okay, well, what else can we do here? I mean, there's many other adjustments that could be out. Because of the state of affairs with this radio, there's no way to know for sure what anybody was doing with it. What they could have done with it. Still have a fat resistor down here, doesn't look good. Still have the old capacitors in it. Let me turn this down. Back to a more normal signal. Full volume. Could be weaknesses in the audio. We never figured that part out. Okay, the whole time I'm asking myself, should I invest in this radio? Like, should I be changing the parts in it, or is this, do everything I can and it's just not going to work well at all? I think that's it for today. One electrocution's good enough. One per day keeps your spirits up. So thanks a lot for watching, and I'll think about all these things I did today, and tomorrow's another day. See ya.